and in this live class, I want to solve some past questions in mathematics, which are examination questions. Let's look at the first one. Number 1 here, we have evaluate 20 base 3 raised to power 2 minus 11 base 3 raised to power 2 in base 3. So we have to evaluate this. We can treat this first. 20 base 3 square. When we square a number, it means the number multiplies itself. So we can say this is 20 times 20 in base 3. So let's get this here. So 0 times 0, 0, 0 times 2, that's 0. 2 times 0, 0. 2 times 2, that's 4. In base 3, divided by 3, that will be 1 remainder 1. So we write the remainder, also we carry the 1. So when we add this here, this will become 0, 0, 1, 1 in base 3. Now, let's keep this for the first term here. Also for 1, 1 base square. So it means we have 1, 1 times 1, 1 in base 3. And here we have 1 times 1, 1, 1. Also 1, 1. And here we have 1, 2, 1. When we had in base 3, so once there is no number here up to 3, we are free to write it. Now, it means that what we have now will be 1, 1, 0, 1, 1, 1, 0, 0 minus 1, 2, 1. So in base 3, we have 1, 1, 0, 0 now. Then minus. Also we have 1, 2, 1 in base 3. Then 0 minus 1 not possible. So we have to borrow 1. Like we take 1 from the next number, and this also is also 0. So come here, we take 1. This one will remain 0, and that one come here become 3. As this, whenever we take 1, it will become the base. So that's why the one we take here become 3 here. Also from here, take 1, remain 2 here, then become 3 here. So 3 minus 1, that's 2. Then here remain 2 minus 2, 0. Here remains 0 minus 1. We still take 1 from here, remain 0 here, then become 3 here. 3 minus 1, that's 2. So here we have 202 to base 3. So that's the final answer here. So you are watching us here live at Master T Math class, and stay tuned to the end of this class. Now, let's look at question number 2 here. Number 2 question, we have to evaluate log 5 base 10 plus log 20 base 10. From what we have here, we can apply the law of logarithm. When we have log a or log m to base a plus log n to base a, here we can write this as log m times n to base a. So let's apply this to what we have here. That means here, this can be written as log 5 times 20 to base 10. That is 5 times 20, that's 100. So we have log 100 base 10. Then here we can express 100 as 10 squared. So we have log 10 squared base 10. Then there is what they call power law of logarithm. When we have log m to base p to raised to power p, this same thing as p log m. Then yeah, this becomes 2 log 10 is 10. And also from the law of logarithm, when we have log a base a, this equals to 1. So log 10 is 10, that's 1. That means yeah, 2 times 1, and that is 2. Okay. So let's look at the next question here. Stay tuned to the end of this class. We have number 3. In this question, we have in a class of 80 students, in a class of 80 students, every student study economics or geography or both. Every student studies economics or geography or both. If 65 students study economics, if 65 students study economics and 50 study geography, how many study both subjects? How many study both subjects? So this is a set problem using Venn diagram, 2 set problem. Let's look at the solution here. We can use Venn diagram here, and here we have the total number of students is the universe set, and the universe set here is 80. So we are going to have 2 circles which intersect. So first we have economics, then 65 for economics, then next we have geography and 50 study geography. Now for both subjects is this region. Let X represent those that study both, which implies those that study economics only. This area is for economics only, so it will be 65 minus X. So those that study geography only, yeah, will be 50 minus X. Then, to get X now, we can add everything here together and equate it to 80. So we have 65 minus X plus 50 minus X equals to 80. And when we solve here, minus S and plus S cancel each other. 65 plus 50 gives us 150. That's 105 minus X equals to 80. We can take 80 to this side, then minus x to this side. And we have 115 minus 80 now equals to x. And here 115 minus 80, here we have 35. So that means x here equals to 35. So that is to that interesting problem on sets. Now, the next question here in this class, question number 4. This question says, if n varies directly as m, and n is equals to 8 when m is equals to 20, find m when n equals to 7. Find m when n equals to 7. This is variation, which is direct variation. And n varies directly as m means n varies as m. Now we can remove the sign of proportionality here. And we put equality sign and a constant. So n equals to km, where k is a constant. Then they say n is 8. That means 8 equals to m is 20. 20 times k, that's 20k. Now to get k here, divide both sides by the coefficient of k, which is 20. And 20 here cancel each other. We have k left, which is equals to 8 over 20. And here 4 goes in 8, 4 goes in 25. That's 2 over 5. Then we can come here and write this equation again as n equals to 2m over 5. So this is the formula connecting n and m. Now find m when n is 7. So when n is 7 now, that means here we are going to have 7 equals to 2m over 5. So cross multiply. This makes 7 times 5, that's 35. So here we have 35 equals to 2 times m, 2m. Divide both sides by 2 to get m. 2 cancel each other here. We have m left here, which is 30 over 2, which gives us 17 and a half. So that is the value of m there. So stay tuned to the end of this class to enjoy it maximally. Now let's look at the next question here, which is question 5. And in this question 5, we have express 0.0462 in standard form. Now, what we have is 0.0462. Now, for standard form, a number that can be written in form of 8 times 10 raised to power n. Here, n could be positive or negative. So it depends. It's in two ways. But a here is a number between 1 and 9, or let's say 1 and 10. Is greater than 1 as it's not up to 10. So it's fall between 1 and 10. So to express this number, in this form now, it means we are going to write this number to be more than 1. So we shift these points until we have a number greater than 1. So the points will be shifted 2 times. 1, 2. Yeah. So we are going to have 4.62 now. Then times 10 raised to power. We shifted it 2 times forward. So it will be minus 2. This is a number less than 1. So for a number less than 1 that started with 0 point something, the power here will be negative. Then the number of times we shifted the points will be the power. So that's minus 2. So here we have standard form of this number. So be 4.62 then 10 raised to power minus 2. Okay. Then number 6 question here. Here we have in a bag of oranges. In a bag of oranges, the ratio of the good ones to the bad to the bad ones is 5:4. So if number of bad oranges in the bag is 36, how many oranges are there altogether? How many oranges are there altogether? So let me give us like 2-3 minutes. Let's attempt this question on the board and let's drop our answer in the comment section before we looked at it together. So let's solve and drop the answer in the comment section. So yeah, okay, let's drop our answer in the comment section. So now let's look at the solution together. In a bag of oranges, the ratio of good one to bad one is 5:4. Now it means this ratio here, it means this here is for good one and this here is for bad one. And the total here is 9. The total ratio is 9. Now, if the number of oranges in the bag is 36, how many oranges are there altogether? Now, let the total oranges be x. Let the total oranges be x. That means for us to get, assuming this bad one is not given, the number of bad oranges is not given. For us to get the number of bad oranges, we are going to say the ratio of the bad orange over the total ratio, then multiply by sorry for the break. So we have the ratio of the bad, that's 4 over the total ratio times the total number is equals to the number of the bad orange, which has been given to be 36. Now let's solve this here to get the value of x. Here we can say 4 times x, that's 4x over 9 equals to 36. Now here we can cross multiply, and here we have 4x times 1, that's 4x, then equals to 36 times 9 here. Then divide both sides by 4 to get the value of x. Then here 4 cancel each other and we have x left. So we can say here x is now equals to, here 4 goes in 36, that's 9. Then times 9, that's 81. So hence here we can say the total number of oranges here are 81 oranges. So that is that for that. So let's look at, okay, let's stop here for tonight. Do well to give your thumbs up, share this video and subscribe. By next class we shall continue from here where we stop, and have a wonderful day. Bye for now.